Hello everyone and welcome. My name is Gavin Soorma. Welcome to the Oracle GoldenGate Advanced Configuration Best Practices webinar. So let's go quickly into the agenda for today as we have quite a bit to discuss. I'll start off with a very brief introduction about the GoldenGate architecture and give you a brief overview of what GoldenGate as a product can do. And the main topics are, as part of the advanced configuration, how do you configure GoldenGate in a cluster, providing high availability on, say, Exadata, for example, and we look at how to use ACFS as well as dbfs to provide the high availability for GoldenGate in a cluster. We'll also look at another, I would think, as a advanced configuration topic, and that is the how do you configure downstream capture, and we'll see how do we configure that, and also when do we actually use this kind of deployment configuration. So I'll spend just a few minutes on giving an overview of the GoldenGate architecture, and we'll go into the other topics as soon as we can. So why do we use GoldenGate? Typically, it's for moving data from heterogeneous environments. Okay, so typically you may have a case where your source database is different, your target database is different RDMS, different platform, different OS. So GoldenGate actually enables us to do heterogeneous database replication. And there's many different use cases for Oracle GoldenGate. It may be to provide just like a reporting solution, or it could be to provide like high availability. It's also used for moving data to big data, for example, so you can integrate GoldenGate with Hadoop, for example. And typically people are using GoldenGate to capture data and maybe also use it for reporting. So you want to point your reporting users from your production database and maybe use a data mart for reporting, and that data mart is constantly populated by GoldenGate. So regardless of the source, regardless of the target, GoldenGate it enables us to do very high-speed replication between two heterogeneous sources and targets. We can also use GoldenGate, the cloud service, to move data to the cloud. So that enables us to migrate the data to the cloud. Heterogeneous databases, again, to the Oracle Cloud Platform. It's not only the Oracle Cloud, but also third-party clouds like Azure, for example. You can use this as real-time data replication via either a hourly basis or like on a subscription basis as well. What are the different topologies for GoldenGate? Normally we use it as what's shown on the top left, the unidirectional topology where data is only flowing one way. In some cases, we're also configuring what's called bidirectional replication. That's typically used for failover. So you have side A populating side B, and side B is also populating side A. So that gives us failover with high availability capability as well. You also have multi-master, and on the bottom left, you can see something called data distribution. Maybe I have needing to broadcast data from, say, head office to the regions. So I'm broadcasting data, and the converse of that is data consolidation, where I have maybe a number of small sources, different varied sources, different databases, different platforms, different versions, and I want to consolidate all that data into a central data warehouse. So these are the different topologies of GoldenGate. The architecture is typically like we have a source database, a target database, and a network in between. As mentioned earlier, the source and target database doesn't need to be the same platform, same version, same OS, etc. How it works basically is that we have a capture process on the source, and that capture process will write data to what's called the GoldenGate priority files, which are the trail files. And then these trail files are propagated over the network to the target, where we have another GoldenGate process, which is called the Replicat. And the job of the Replicat process is to basically apply changes to the target database. And this could also happen in the bidirectional manner as well. So what's the classic extract? The classic extract is basically an extract that runs outside the database. So the reason why I'm showing you this is because when we talk about downstream capture, we are using the integrated extracts. And typically when people want to use integrated extracts, but they can't run anything in the source database, then we have what's called a downstream capture, where the data is being captured from inside the database, but it's receiving the data from the source. So we have an intermediate database, which is the downstream capture, And I'll talk about that in a little more detail when we talk about the downstream capture part. So the classic extract is just looking at the read log files for Oracle, or maybe if it's SQL Server, the transaction logs, writing them to trail files. But we have another GoldenGate process which is called the pump, not to be confused with Oracle export import data pump. The GoldenGate pump process writes data over the network to the target side, and where it's picked up and applied by the Replicat process. So the key thing to keep in mind here is that the classic extract is totally outside the database. When GoldenGate first came into being, I think version 10, it was the only kind of extract that was available, and then later on Oracle has introduced another extract which runs inside the database, and that's called integrated. And typically you'll use the integrated extract when you have things like RAC, ASM. If you're working with compressed data, for example, if you're using encrypted data, that's where the classic extract may not work, and then in that case you have to deploy the integrated extract. So here's an example of the integrated extract. It needs versions 11.203 and above, where we have what's called a database log mining server. So the log mining server is like your streams, very similar to the streams engine. It's mining the read log files and writing what's called logical change records. And then these logical change records are basically handed over to GoldenGate, where the GoldenGate extract process will use those logical change records, write them to the GoldenGate trail files, and then again they're sent over the network by the pump process. So the difference with this is that we do have, unlike the classic extract, with the integrated extract, it's running inside the database, so it does spawn a few database sessions and processes, and those are typically the log mining server, which is running inside your Oracle database. So the integrated extract is only for the Oracle database. You cannot use the integrated extract with, say, SQL Server, for example. So here's an example of some of the processes that run inside the log mining server. You have a reader process, and then a preparer process, builder, capture process. So they all perform different functions. For example, the reader will read the log file, and the preparer will scan the log file. The builder will merge the prepared records in the order of the SCNs. The capture process is the main process that formats what's called logical change records and then hands them over to the GoldenGate extract process. Similarly to the classic extract, you also have the classic Replicat, where you have, again, the Replicat is running outside the database, in this case, the target database. The Replicat just reads the trail files that are sent from the source, typically by the pump process, extracts the changes in the form of SQL statements, and then just applies them as inserts into the target database. Like the integrated extract, we also can use the integrated Replicat, and that again is for Oracle, but it has a lot of advantages over the classic Replicat. Again, it uses what's called database inbound server, which is very similar to the log mining server, which the integrated extract is configured with. The Replicat process reads the trail files, extracts logical chain records, and then passes them on to the inbound server or the log mining server engine on the target. And finally, there's an apply process that applies the changes to the database tables. So again, like the integrated extract, the integrated Replicat has its own internal processes. Again, these are running like log mining server engine. So you have the receiver, the preparer, the coordinator, and the biggest advantage of the integrated Replicat, and why I would advocate using integrated Replicats if you're running on Oracle 11.204 and above, is that it spawns apply processes on the fly depending on the load. So you can specify a minimum and a maximum number of apply processes. So these are parameters that you configure your Replicat with. And then depending on the load, the number of logical change records that the log mining server engine is processing, it can spawn additional apply server processes on the fly. And that actually will add throughput to your apply process automatically without you having to configure what are called multiple parameter files, for example. So that was just a very brief overview of the architecture of GoldenGate. So let's dive into our first advanced topic, and this is how to configure Oracle GoldenGate in the cluster. We're going to look at two different methods of configuring GoldenGate in a cluster. One's using the ACFS, which is the ASM clustered file system, and the other one is using what's called the database file system, or DBFS. So with ACFS, the first thing that we have to do is that we have to go and create a ASM cluster file system. So we create an ASM disk group, and then we create an ASM volume, and then from ASM configuration assistant GUI, or if you want, you can use ASM CMD command line method to go and create a ACFS ASM cluster file system. So in this case, we have a volume called OGG vol, and we had a disk group called ACFS. So you create the ASM disk group first, then from the disk group you create a volume, and then that volume is used to create a ASM cluster file system, also known as ACFS. We got to run a few scripts as root, and that actually goes and mounts the ACFS file system and registers it with the Oracle Clusterware. So that's the first step, and then after that, when we start the installation of GoldenGate, so this is the standard run installer screen you would see when you install GoldenGate. We don't specify the local directory that we normally use to specify in a non-cluster setup. We specify the shared ACFS cluster file system location. In this case, it's /OGG. So what we have to do now, after we have installed GoldenGate, now we're looking at the parameter files, and in a cluster environment, what actually happens, the Clusterware processes are only dealing with the manager. So all it does is that it brings up the manager. Let's assume the manager is running on node A, and node A goes down. What Clusterware will do, and we'll see how it's done, we'll bring up the manager process on node B, and after that, once the manager process is brought up, Clusterware says, okay, I've done my job, now you go and do your job. And what the manager will do in that case, it goes and starts up all the extract and replicate processes, the pump processes, as the case may be. So a very important parameter that you have to specify in the manager file, parameter file. Remember, you only need one parameter in manager by default, just the port. But these are some additional parameters that I've shown here, some best practices to set up the manager parameter file. The lag parameters you see there is typically for alerting you and warning you if the lag exceeds a particular threshold. You can specify what threshold you consider to be critical, on what threshold you consider to be non-critical, just informational. The important parameter out here that you need to keep in mind for a clustered environment is to ensure that the auto start parameter is set, because what actually happens, the manager process will start, and if you look at auto start, in this case saying auto start extract, all the extracts that start with E, and auto start the extracts that start with P, and if we are using replicates, also start the replicates. So you may say, how come we're starting the extracts and replicates? So this could be a case where I have bidirectional replication configured, where I have both the extracts and the replicates running on both the sides. So that's the main parameter I need to keep in mind. Ensure that my manager process will automatically start up my extracts and replicates and pumps, because Clusterware is not going to start up any of these processes. It will just start up the manager. So here's an example, like configuring the integrated extract. When we configure the integrated extract, we have to register it with the database. So you can see the register command being shown there. And what it does, it goes and creates a capture process. So if you have used streams in the past, then you would have seen a capture process showing up in the DBA capture view. And here it has the name $cap followed by the name you have provided for your extract process. So you can see that it started capturing data at a particular SCN. So that's when you register the database. So changes that have happened before this SCN are not captured by this particular extract process. So when you register the extract, keep in mind the SCN number from basically where the extract process is picking up changes from. So here we have a look at the manager, and we can see in this case, I'm looking at a 2-node rack cluster. My node names are rack 01 and rack 02. And I have configured GoldenGate now to run in the cluster and using the ACFS file system. I can see now on the node 1, if I look at port 7809, which is the port I have configured for the manager, I can see the manager process is running. And if I connect to node 2, I see that the manager process is not running. So the manager process is only going to run on one node, not both nodes. So basically, it's down one node. And in the event of a failure, Clusterware will bring up the manager process on a surviving node. And when the manager process is brought up, using the auto start parameter that's configured in the manager parameter file, all the other dependent processes like the extract and the pump and the replicate are also started up automatically. So we have configured the manager. So we installed GoldenGate using the ACFS file system. And now we have to integrate GoldenGate with Clusterware. So we have to configure what's called an application VIP. So why do I use this VIP? Basically what happens is that if the node fails, this VIP is failed over to a surviving node. So I have to use an unused IP address. So I've got to work with my network guys for this and use the command called app VIP-cfg. So that's available in the grid home bin directory. The default network is 1. And this VIP name is registered in DNS. So I have to ensure that this name that I provide for my VIP is resolvable by DNS. Sorry. After that, I have means of this resource to the GoldenGate user, and I can test that with this resource is being relocated. So I want to ensure that this that I create is being failed manually, and just ensuring that I don't get any errors, because I want this to automatically happen. So I'm just to see whether the failover happens manually for what's called the application VIP. So I start the resource initially on rack 0. I can see that when I run the ctl status command, it's running on. I can then do a failover to another node. Okay, so we create the application VIP, all right, and then what we do next is a very important step. This is another piece of software taken that way that we have to download. There is a link available on OTN where I can download the grid infrastructure agents, and I think version 9 is the latest version. What this do is that they provide us some kind of management framework and high availability framework, and it's not only for GoldenGate but for other Oracle products as well, like Tomcat web server, Apache web servers, Sibo. So it basically provides high availability and management framework for all these types of resources. GoldenGate is also considered as a resource now. So it enables us to present these applications, that's GoldenGate or the Sibo, as the resource that's managed by Oracle Clusterware. So the key thing here is that grid infrastructure agents integrates these applications with our installed Oracle Clusterware. So obviously the first requirement is that we have to have grid infrastructure set up, and on top of grid infrastructure we can download the grid infrastructure agent software and install it. So here's an example of, I think, version 7.2. So like I said, the current version is 9. You've got to basically download this zip file and unpack it, and then using the xag setup.sh install this on both the nodes. So you can install it in any directory you like. The basic key here is to ensure that you use the all nodes flag, and you can see out here it's installing grid infrastructure agents on rack 01 and rack 02. Once that is done, we use a executable called agctl, or agent control. Agctl is for grid infrastructure agent. So running this command from where? The bin directory that we have set up out here. So when we basically install the grid infrastructure agent, we specify a particular directory here, and under this directory it creates a number of subdirectories. Subdirectory bin is one of them, and then we launch agctl from there, and let's have a look at the different arguments we provide for agctl. So we say agctl add GoldenGate. So GoldenGate is one of the resources, so that's a keyword, and I give it some name. So the name here is ogg_ha. You can provide any name. Specify my existing GoldenGate home. So note the ACFS GoldenGate is basically installed on /ogg. So that's my home. I specified the nodes. I specified the application VIP that I had created earlier. Then the file system. So the file system in this case is the ACFS file system, my database, the Oracle home for the database. And I can also specify if I want to consider some extracts as critical. If I consider some extracts as critical, and just for any reason they are down, when I run an agctl status GoldenGate resource, if one of those extracts or replicas that I've defined as critical is down, it will show the entire resource as down, even though I may have 5 extracts and 4 are running, but the one I defined as critical is not running. It will show the entire GoldenGate resource with the status of being down. So here we start the GoldenGate resource using agctl again. Once it's started, I can use agctl status GoldenGate, and I can see in this case it's running on a particular node being rack 01. The agctl config command will give me more information about how this GoldenGate resource has been configured using the grid infrastructure agent. So it gives me a location of GoldenGate. We can see which nodes GoldenGate is configured to run on, the VIP name, the file systems, any extracts that I have defined as critical. So in this case, we have not defined any replicats as critical. We just defined one extract as critical. Basically, if you're using DataGuard, we can also configure GoldenGate to start automatically as part of a role transition. So what do I need to do on the GoldenGate side? There's an important parameter that I have to specify in what's called the globals file. So the globals file basically is like a parameter file, but it applies to your entire GoldenGate environment. So rather than put this parameter in every extract or pump or Replicat parameter file, I can put it just one place, and that is the globals file. So in this case, I have to add the entry xag enable into my globals file, and I need to importantly keep one thing in mind. Any change I make to globals is only read next time GoldenGate is launched via ggsci. So when I launch ggsci, the globals file is read, and if I run the info all command now, I can see that the manager has been integrated with xag.ogg_ha, which was the name of my GoldenGate resource. So xag is the grid infrastructure agent. If I stop the manager, so it's not recommended to basically stop stuff like managers or extracts or replicats from within ggsci once you have configured it to work with the grid infrastructure agents. But I'm just showing an example out here. If I stop the manager from the ggsci interface, it tells you that transparent integration with xag is enabled, setting the stop manager command to xag. So even though I stop the manager from the GoldenGate interface, ggsci, if I check agctl command with status of GoldenGate, it says the GoldenGate instance is not running. If I start the manager, I can see that because of the integration with the grid infrastructure agent, I run the command and it shows me now that the GoldenGate instance is now running. So stopping and starting the manager from within GoldenGate infrastructure, because I have the xag enable defined in my globals file, it enables GoldenGate to communicate with the grid infrastructure agent. So basically what it's doing, it's Clusterware is being made aware whether GoldenGate is running or not, even though I have not actually started GoldenGate using agctl. But like I said, the best practice is to always use only agctl to manage GoldenGate. So like saying, like, if you have a rack database, should I use srectl or should I use SQL Plus? I would say use srectl because SQL Plus is not really integrated with your Clusterware. So let's have a look at simulating a failure here of a node. So in this case, I check the status of GoldenGate resource via agctl. I can see that it's running on rack 01. So I simulate a node failure by shutting down rack 01. Then I go to rack 02 and I check the status initially while the failover is happening. If I run the agctl command on rack 02, it initially tells me that GoldenGate instance OGGHA is not running. And after maybe a minute I try the same thing, we can see that GoldenGate instance now has been failed over automatically to rack 02. So if I connect to rack 02 GoldenGate environment, so because /OGG is shared, even though rack 01 is down, the ACFS file system is available on rack 02. And using the info all command, I can see that the manager is running. And because the manager is running, it has also started up the extract automatically for us. So if the extract was processing anything and node 1 crashed, the extract process is brought up automatically on node 2, and it knows where it has processed. So GoldenGate has got its own checkpoint file. It knows up to what point in time the extract had processed before it crashed. Now the manager has started up the extract process, and it continues processing from that point onwards. Let's have a look at the similar setup of high availability using GoldenGate, integrating them with the grid infrastructure agents, This time, instead of using ACFS, we'll use something called dbfs or database file system. So what is dbfs? It is a file system that is stored inside the Oracle database, introduced with Oracle versions 11G. What it does is stores file system objects as in tables, as large objects or lobs. And it enables us to access this file system using a client program called dbfs_client. And right now, I think it's only available on Linux and Solaris. It also requires something called fuse to basically give you permission to access dbfs. So if you're using Exadata, for example, one of the disk groups that gets created out of the box is the disk group called dbfs_dg. And this is the disk group you will use to basically set up your dbfs or database file system. So I have a ASM disk group in this case called dbfs-dg. We need to do some configuration. That is basically ensuring that we have a group called fuse existing, and then there's a file called fuse.conf. We have to add some. We have to add a line called user_allow_other to the etc/fuse.conf file and set permissions appropriately as shown here. We create a mount point on both the nodes, again rack 01, rack 02. So we create a mount point called dbfs. And now what we have to do is go and create a tablespace using the dbfs ASM disk group. So here we have created a tablespace called dbfs_ogg. In this case, it's using the dbfs_dg ASM disk group. And after that, we have to create a dbfs user, grant it some appropriate privileges and roles as shown here. So there's a role called dbfs role, and it needs create session, create table, create view, and create procedure as well. So create the table space, create the user, go to Oracle Home rdbms admin, and we have to run a script called dbfs create file system. We give it a name, and we specify the table space name that is going to host all these objects. So the table space which we created earlier, we called it dbfs_ogg_big, and I specified that out here in the dbfs create file system as one of the parameters. So once that is done, it goes and creates a number of different tables, and we can see those tables under the dbfs user. Now in Exadata, there's a particular My Oracle support note that details how to basically set this up on Exadata, and also can be applied to non-Exadata platforms as well. So what we basically have to do is that this particular note, 105.4431.1, it has a few attachments. One of them is called the mount-dbfs and the version.zip file. So you may find that the version is different now. I think it's pretty old, this one, 2016. So the version may have changed. Once we download this file, we need to use what's called Unix to convert that to Unix format, because sometimes it has some extra characters or digital characters, and you may find that when you try to launch it, it'll give you errors. We need to copy this mount-dbfs.sh script to the Oracle grid home in the directory called CRS script. Change the ownership to Oracle, because Oracle is my my GoldenGate user as well, my database user. And there's also another file. So two files. When you unzip the zip file, you'll see mount-dbfs.conf and a similar file .sh. So copy the sh file to CRS script directory under the GI home, and copy the mount-dbfs.conf file to etc Oracle. So once we have this wrapper script, we need to go and make a few changes. For example, put in our mount point, put in our database name, our dbfs user, on the Oracle home, what is our grid home, the dbfs password. So what it does actually internally, it will use these details to try to connect to the dbfs file system. So that's how we specify the Oracle home and the database and other things. So this is the mount-dbfs.conf, copy it to etc Oracle. And then what we do, we use the mount.dbfs.sh script to start the file system. So what it does, you can see out here, when I launch mount-dbfs.sh with the start argument, it's mounting dbfs /dbfs, which is my file system mount point. So I can test this and also use the stop argument as well. What the stop argument does, it will go and unmount the file system. So when I run the mount mount-dbfs.sh start, I can actually go and do a df command, and I'll see that /dbfs will be showing up as a mounted file system. Another script we have to add, this is actually creating what's called the cluster resource. So I can just create a file with any name. So I've chosen the name as add-dbfs-resources.sh. It needs to be again in the CRS script directory and in the grid home. And this actually is specifying which script do I call. So here it's calling the mount-dbfs.sh script. The script which I basically downloaded from my Oracle support, and I changed some parameters when I showed you in the earlier slide. The resource name here is actually dbfs-mount. What is the dependency? The database should be running, because yes, the file system is inside the database, so I need the database to be up and running first, and I specify my Oracle home location of my grid infrastructure. So this is called like an action script. If I launch the crctl command, because now I've registered a resource, it shows up in Clusterware with the crctl command. I can see in this case it's offline. I can then use crctl to start the resource. So what we've done in this earlier step is create this cluster resource called dbfs-mount. Okay, so it could be any name. The rest name which you see out here in the script that we're creating actually will specify the resource name. So once I have resource name called dbfs-mount using crctl, I can start and stop that as well. So once I start the resource, if I run a df command, I can see that the dbfs file system is mounted in the mount point called /dbfs. And once I stop it, the file system is basically unmounted. So the difference between the GoldenGate setup for dbfs and the ACFS is that here we install GoldenGate individually on both the local directories. So rack 1, rack 2, for example, I will install GoldenGate on U01 app Oracle OGG, which is a local directory, and this directory may be present on both the nodes. Whereas earlier with ACFS, we installed GoldenGate on the shared cluster file system. But what we have to do, so we'll give you a warning saying that this is a grid infrastructure environment, Clusterware is running. Looks like you have not selected a shared directory. You can ignore that. So that's my software location. What we need to do after that is, these are the directories that are there. So we need to go and create some shared directories on dbfs. So we go to our dbfs directory and we go and create some shared directories. Now what actually is happening here is that some files of GoldenGate, like your parameter files, report files, your internal files that are used by GoldenGate, like your checkpoints, and there's another directory called BR, which is boundary recovery. GoldenGate needs to have access to these directories regardless of which node GoldenGate is running from. So all these directories, which are normally created on the same software location directory, put it that way, home. So if I'm not using GoldenGate for a cluster, all these directories would be in the GoldenGate software installation home. But what we're doing out here, we're creating some directories which need to be shared on the dbfs file system. After that, we have to go to our GoldenGate software home and create symbolic links from the original GoldenGate directories like dr, chk, dr, crd, dr, dat. So dr, dat is where my trail files are. So I rename the original directories to something else, and then I create symbolic links from the GoldenGate local directory to the dbfs shared file system. So I need to do that on both my GoldenGate software's homes, which are on this case rack 01 and rack 02. So similar to how I configure the manager process for ACFS, that would remain the same even on dbfs. No difference in that. So the important thing here is to ensure that the auto start is enabled for all the parameters. And then again, using the grid infrastructure agent, I run the very similar command, agctl. The difference being out here is that I specify the file system, in this case as dbfs, as opposed to the ACFS. Other than that, everything else would remain the same. So GoldenGate files now are located on dbfs. So if I go to my dr.dat directory, and that is under my dbfs file system, so there's a directory called dr.dat. Remember, I've created symbolic links to this directory. So now, even though I'm in dbfs, and if I connect to any of my rack nodes and go to the local GoldenGate directory under dr.dat, because it's a symbolic link to the dbfs file system, I'll be able to see the files either from rack 1 as well as from rack 2. So we can see out here, similar to dr.dat, another very important shared directory is the directory that holds the parameter files, or drprm. So again, we'll test the high availability of GoldenGate using dbfs this time, and in this case, we can see GoldenGate is running on rack 1. I'm going to shut down rack 1. So when I shut down rack 1, I am basically trying to simulate a case where I've lost my node where GoldenGate was originally running from. I go on to rack 2, and using the same agctl command, I can check what's the status of GoldenGate. So it shows initially it's not running, and then after maybe 30 seconds or 1 minute, I can check, and I can see now the dbfs file system is mounted on rack 02. So the dbfs file system will only be mounted on one node. It's not going to be mounted on both the nodes. Okay, so keep that in mind. Clusterware will fail over the resource to another node, and the dbfs file system will be mounted on the node where it has been failed over to. So I can run the agctl command again, and now I see that GoldenGate is running on rack 02, and the dbfs file system has also been mounted on rack 02. So that was a bit brief look at some of the high availability that I can use with GoldenGate and a rack cluster, for example, and dbfs is normally the method we use for Exadata. And ACFS, even though support on Exadata, is not used that much because we have the dbfs DG disk group that's automatically created when Exadata box is delivered to you. It's not saying that you can't use ACFS on Exadata, you can. But I would say, let's say that in most cases I have seen non-Exadata are using ACFS and Exadata are using the dbfs method of deploying the high availability of GoldenGate. So let's have a look at another, what I would call advanced configuration, and this is the downstream capture deployment. Typically, we have two types of deployments when I'm using integrated capture. So what's the difference between classic capture and integrated? Classic capture, GoldenGate process running outside the database, just reads read log files and writes to trail files. With the integrated GoldenGate, the extract process is running inside the database, inside the Oracle database, and working with the log mining server engine to extract the logical change records and write them to trail files. So there's two deployment options I can use with the integrated capture method. One is local deployment. So think of it as a mining database. So here the source and the mining database are the same, one and the same. So I don't have a separate database just to install and configure what's called a log mining server. But with the downstream deployment, the source database is 1, the mining database is 2, and the target database is 3. In some cases, I've seen people are treating the source as 1 and the mining and the target database as 2. So I basically have my log mining server running on the target, okay? Or what they're doing, because this mining database doesn't really contain any data, it just has a control file and it's just receiving the log files shipped from the primary database or the source. It doesn't have any real data, so the footprint is pretty small. So you can create a separate database just for the to run the log mining server engine, which is your downstream capture database. So the difference between local deployment and downstream deployment, the source and mining databases are different, and the log mining server is created in the downstream capture database as opposed to the source database. So what does downstream capture deployment essentially involve? It involves something very similar to what we have done with DataGuard. And what is that? We configure redo transport at the source database, and the source database that ships the redo to the downstream capture database, where the log mining server now is sitting in the downstream capture It receives the log files that are shipped from the primary. I would say the primary now is the source. And what it does, again, it does the same thing that the integrated extract was doing in the local deployment, which is extract the changes in the form of logical change records and hand them over to the integrated extract, which are then written to trail files. So why do we sometimes use the downstream capture? This is to offload any kind of overhead that's associated with the log mining server engine. So if some people have concerns that the GoldenGate extract process is going to add overhead, or maybe there could be a case where you're not allowed to do any changes on the production, but you want to configure GoldenGate. For some reason, this production is locked down, you don't have access to production, then you can create the downstream capture database in your environment. All you have to ensure is that the source database is configured to just ship the archive log files. So there's nothing running inside the source database. All we're doing is adding another log archive destination. And then what's happening is that the archive log files are being shipped from the source to the downstream capture database. We can configure our downstream capture database to use either standby log files, or if I use standby log files, then it's obviously real-time capture. That means as soon as a change is committed on the source, that change is captured by the downstream capture process without waiting for the archive log file to get filled. So for that, it needs what's called the standby log files. Otherwise, if I don't have standby log files, the archive log file needs to get filled and then shipped from the source to the downstream capture, and only then it will be processed. So here's an example of what I was just saying. So keep in mind that the downstream capture, yes, it's Oracle. So it's using some kind of data guard technology here for read transport. So read log files are shipped via read transport to the log mining server, where the integrated extract process is running, and the log mining server is handing over logical change records to the GoldenGate integrated extract, and then the GoldenGate extract process will write those changes to the trail files, from there they're sent over the network to the target, and then on the target we have the Replicat process taking over. So this means that basically what's mentioned in this slide is that when changes are being written to the archive log files, to the online read log files, they're also being written to the archive log files. But if I'm not using standby log files on the target, which in this case is the downstream capture, then obviously the archive log file has to get filled and then shipped, and then only the log mining server on the downstream capture will process that. The downstream capture database can also be configured with standby log files, which will receive review data as soon as the transaction is committed on the source. There's an RFS process. The RFS process basically writes these changes to the standby log files. So this is called real-time apply. So there's the parameter that we have to specify, whether we want real-time apply or not. I think I'll show it's there on the slides. Just bear with me. So let's have a quick look at how we use the downstream capture deployment method. If I'm not using standby log files, the RFS process will only receive changes once the entire archive log file is filled up. So in this case, we have a source database. The log writer process is writing to the online log files. So this is like very similar to data guard. Video transport is being involved here. Either I'm using the ARC process, in which case the archive log files gets filled and then only sent to the RFS process. Otherwise, if I'm using standby log files, the RFS process will capture changes as soon as they're committed on the source, writes to standby log files, and then they're picked up by the log mining server engine. Once they are processed for the log mining server engine, the standard GoldenGate processes kick in, like the integrated extract, which writes to the trail files, and then these trail files are sent over the network to the target, where the Replicat process will pick up those changes and then apply them to the database. So let's look at some of the key steps in configuring the Oracle downstream capture with GoldenGate. So one of the important things we have to do and keep in mind is that I need to ensure that supplemental logging is enabled on the source. So yes, it does add a little overhead. That means there'll be some additional archive logs being generated. So keep that in mind, but this is a requirement. So I have to ensure that supplemental logging is turned on. So auto database adds supplemental log data. And I have to create the downstream capture database, so I can create that via DVC as well. Important thing to keep in mind is that when I'm creating the standby log files, they should be the same size as the read log files on the source. And normally we create one additional standby log file as compared to the read log files. We have to allocate memory to the downstream capture because I need memory. A typical rule of thumb is 1 GB to be allocated to the stream spool size per extract process. So if I have a number of extract processes running, I need to appropriately allocate memory to the stream spool size, because this one regulates how much memory is allocated to my log mining server engine. So the downstream capture database really doesn't have a big footprint in terms of data because there's no data being stored, but it could be, we need to ensure that the downstream capture database SGA is large enough to ensure that the stream spool size is configured properly. Otherwise, we may find that some processes are giving some errors, or my extract process is not starting up because the log mining server does not have enough memory to process the changes that are happening. So if your stream spool size is set too small, you may find that my extract processes are encountering some errors. So the normal rule of thumb, which has been mentioned in the documentation as well, is that we need to allocate 1 GB of memory per extract process to the stream spool size. We create the GoldenGate user. So that's pretty much common, even if I'm not using downstream capture. Just ensure that I need to create this user in the downstream capture database as well. So I have a GoldenGate user in the source, in the downstream capture, as well as in the target. So that's a bit different. And also run the dbms underscore GoldenGate auth to grant the admin privilege to the GoldenGate user. Okay, so on the source and as well as the downstream capture, so this parameter is, for those who have used DataGuard, would be quite familiar. So you need to set the log archive config equals dg underscore config, and you put in the DB unique names. So in this case, my source is called source DB, my downstream capture is called OGDB. So ensure the log archive config parameter is set to this value, which is the DB unique name. All right, so again, very similar DataGuard parameter. So if you use DataGuard, this parameter should be quite familiar with this parameter. So I set the log archive dest2 in this case. So this assumes that my source is not having any existing log archive dest2. Maybe it's already shipping data somewhere. In that case, the log archive dest could be 3 or 4, whatever. I specify the service or the DNS status of my downstream capture. That's my log archive dest2, and just enable that. As mentioned earlier, I need to create my standby log files. This is for ensuring real-time capture. And because this example is with rack, I need to create 2 threads, all right? And we need to ensure that the number of standby log files is more than the read log files per one at least. So very similar to my DataGuard setup, I have to ensure the password files are synchronized, otherwise I get some errors. So copy the password file from the source Oracle Home DBS directory to the downstream capture machine, Oracle Home DBS directory. We also have to ensure, this is a bit important, I need to create a separate directory which will hold the archive log files that are received from the source database. Now let's look at just the downstream capture. Now the downstream capture is making some changes, right? Some changes, it's processing data, so that's change. So it has its own read log files, and when the read log files are getting filled, it's basically archiving files as well. So it needs, in addition to its normal directory that it stores its archive log files in, which typically is the DB recovery dest, it also needs an additional directory, and these are the archive log files that it's receiving from the source database. So we create another directory to store the archive log files that are received from the source. So you can see out here, I'm setting up two archive destinations here. One is using the use recovery file desk. So this is the for the archive files that are being generated locally by the downstream capture. And I'm also specifying a separate location, and I'm just calling it like remote. And this is valid for standby log files because they're being received from the source. So I configure log archive dest 1 and 2 on the downstream capture. So on my source, I can query the destination is valid or not using the v-archive dest status, v$archive dest status. Now here is something a bit different. When I'm creating the extract in the pump, just note the logins that are being used. So this is my GoldenGate target environment. So I have GoldenGate installed on the target, and on the target machine, I have two databases. One is the downstream capture, and the other one is the actual target database. So I have one instance of GoldenGate on the target installed. So I have a DB login first. So this is like if I'm using a credential store, so I have DB login, user ID alias, and some name. So you can see out here, the user ID alias is the source database. Then I connect to the mining database. So here the mining database is nothing but the downstream capture. So I have to establish a connection to the source database, and I also have to establish a connection to the downstream capture database using the mining DB login parameter. So my mining DB login. So here you can see in this case, the user ID is the user for GoldenGate in the downstream capture database. So we can see here successfully logged into the mining database. And that after that, I can go and create the integrated extracts. I register the integrated extract now with the database. So which database is this actually getting registered with? This is with the downstream capture and not with the source database. So when I issue this command, register extract name database, it takes a mining DB login to determine which database should I connect to. So I just have to establish like a proxy connection to my source, but no changes are really happening in the source because we said we don't want any extract processes to be running from the source. I don't want anything to be created. I don't want any log mining server to be running in my source. All this has to happen on the downstream capture database. So that's being done through the mining DB login that I specify. So you can see out here a couple of parameters I have to specify in my extract file. So you can see there's tran log options, mining user alias. Okay, so this is similar to what I used here to connect. Mining DB login, user ID alias is OGG user, OGG DB. So you can see the tran log options, mining user alias, OGG user, OGG DB. And tran log options, I can specify some more parameters for my integrated extract. One of them is pretty important. Here I'm specifying downstream real-time mining is set to Y. That means I've configured standby log files on the downstream capture. When a transaction is committed on the source, the RFS process is going to write it to the standby log files, and then it's going to be processed by the log mining server engine on the downstream capture and handed over to the GoldenGate extract process straight away without waiting for the archive log file to get filled on the source. So that's an important parameter to keep in mind if I want to have real-time mining enabled. If for any reason I don't want to have real-time mining enabled, then you can basically set this to no. But then what's going to happen is that only when my archive log file gets filled, only then it's going to be processed by my downstream capture log mining server engine. So that means if the size of the archive log file is pretty big, there could be some lags because the downstream capture has not received the changes as yet. So it's basically just waiting. And when the archive log file gets filled finally, then the RFS process says, okay, fine, I'm going to hand them over to the downstream capture database, and then from there it's basically processed. So here we can connect to the source database, and if we query DBA capture, we can see that the query select capture name from DBA capture returns actually no rows because we have created the integrated extract, which in turn will create a capture process in the database, and that's happening in the OGG-DB database. So this is just to show you, verifying that. I connect to the source. There's no rows returned because it's not running there, but it's running in the downstream capture. So select capture name from DBA capture on the downstream capture database will return a value, so I can see that there's a capture called OGG$cap followed by the extract name. So guys, I think the speed has been a bit fast. I had to cover quite a bit in a short time. But if you do have any questions, please do ping me. My email address is there, prosolutions@gavinsoorma.com. You can also reach out to me via my website. I hope you have found the session informative and would request your feedback as well. Thank you for attending and have a good day. Thank you.